Hello, Ashik. Hello.
Yes, sir. Yes, yes.
Can you hear
Yes.
me?
Yeah, yes, we can hear you, sir.
Shall we start within 1 minute,
Sir,
right?
can we? Yeah, we can start in 1 minute, sir.
Sushant sir, good evening, sir.
Good evening.
Sir, how are you?
I'm good. I know this is a little late for all of you guys, so I apologize for this timing.
No issues, but because usually we conduct during the office time.
Yeah.
Now it is very late and people are in the house. So this is a weekend. So people are
Yeah.
traveling out.
Yeah, and that's what I was thinking. It might be tricky, and I don't know. Time might be off for a lot of you, but thank
So
you for
we are
everybody who's
we are
shown up.
recording this also. then we will give these recordings also to them. No
Okay.
issues, sir.
Okay. Thank you.
Ashik, shall we start, Ashik?
Yeah, we can start, sir. We can start. Anisha?
Am I audible?
Yes.
Yeah, you are audible. Yeah, please.
A very warm good evening to one and all present here. I'm Anisha, project staff at National Transportation Planning and Research Center. It gives me immense pleasure to welcome you all to the 22nd talk of TransTech Talk series organized by KSCSTE National Transportation Planning and Research Center. This talk series is yet another unique venture of NATPAC, designed to explore diverse topics from cutting-edge technologies to sustainable solutions. Here, we will be featuring eminent researchers to share their valuable insights for kindling the spirit of future research and development in transportation. Today, we have with us Dr. Sushant Sharma for sharing his valuable insights on the topic Freight Technologies and Strategies for Resilient Future. Now, I request our Honorable Principal Scientist, NATPAC, Dr. Shaheen Yas, sir, to deliver the welcome address. Over to you, sir.
Good evening, all. Welcome to Sushant, sir. NATPAC, KSST-NATPAC has introduced a specialized segment of its technical discussion series titled TransTech Talk series, which focuses on the latest development, challenges, and innovations in the field of transportation. This monthly lecture series covers diverse topics in traffic and transportation, featuring experts from all over the world. The TransTech Talk series provides a dynamic platform for discussing the most pressing challenges and opportunities in the transportation industry. By bringing together experts and innovators, the series contributes to the shaping of the global mobility, creating smarter, more sustainable and resilient transportation networks. Through expert-led discussion, practical insights, and collaborative learning, this series enables professionals and enthusiasts alike to stay ahead of the curve in one of the world's most critical infrastructure sectors. To date, we have completed 21 such lectures. The 22nd talk in this series, organized by Transportation Planning Division of NATPAC, will be delivered by Dr. Sushant Sharma, Assistant Program Manager and Research Scientist in the Multimodal Freight Program of the Texas A&M Transportation Institute, USA. It is with great pleasure and enthusiasm that I stand before you today to extend a warm welcome to our distinguished speaker, who has graciously accepted our invitation to share insights and knowledge in the realm of freight technologies and strategies for resilient future. After the presentation, we will have a question and answer session where you can post your questions and engage in a meaningful dialogue with Dr. Sushant Sharma. Feel free to participate actively. I once again thank you for being here today, and let us give our warmest welcome to Dr. Sushant Sharma as we eagerly await the insights he is about to share. Thank you, sir.
Thank you, Dr. Shaheen. I would like to start. Can I start now?
Yeah, now there is an introduction also, sir. 1 minute.
Okay.
Thank you, sir, for your amiable welcome note. Now, I would like to invite Sri Ashik K. Azad, Junior Scientist at NATPAC, to introduce the speaker to the audience. Over to you, sir.
Thank you, Anisha. Good evening and good morning to one or all who joined the meeting. It's my pleasure to address the the speaker intro to this session. Dr. Sushant Sharma is an assistant program manager and research scientist in the multimodal freight program of the TTI, Texas and A&M University, the USA. He has 17 years of experience and expertise in freight mobility, transportation planning, network modeling, travel demand modeling, big data analysis, and traffic operations. Dr. Sharma has worked on numerous research and consultancy projects sponsored by FHA, NCHRP, US Notes University Transportation Centers, and state DOTs in the US. Dr. Sharma is also a senior associate editor of the Transportation Research Records and serves as a reviewer and subject matter expert for nearly all transportation related journals. Nationally, he serves as a freight transportation planning and Logistics Committee of the Transportation Research Board, TRB, and ASCI's Freight and Intermodal Logistics Committee. He is a member of the TRB Standing Committee on Disaster Response, Emergency Evacuations and Business Continuity. Internationally, he chairs the Freight Transport Modeling Group of the World Conference on Transportation Research Society. TRB committee led by Dr. Sushant received the 2023 and 2024 Blue Ribbon Awards for implementing research into practice and promoting committee diversity. Dr. Sharma also received a Best Research Award from the TTI in 2023. I welcome you, sir, for the talk. Over to you, Anisha.
Thank you, Ashik sir, for the meticulous introduction. Now I invite Dr. Sushant Sharma to deliver the talk. Over to you, sir.
Thank you. Thank you, everyone, and NATPAC for inviting me. I typically don't start my talks with apologies, but apologize to everybody whose weekend I might have ruined today. I know everybody might have a good plan, and now you're sitting here listening to me. I promise to deliver something for you. Please feel free to participate and ask questions, and I'll be able to respond to you if you ask me these questions later on as well. Like, you can just mention that you were there that day, and I'll respond to your emails as well. Now, with that, I have kept, when I started developing this presentation, it took us like a little bit 4 or 5 months to get this scheduled. And that was partly because of my schedule and the timings were a little off. But when I started developing this presentation, I kept it at a very high level. I made an assumptions there about the audience, like who my audience is and what NATPAC does. So if I don't go deep into something, you can ask questions related to that. And if there's like, you feel like we're going tangentially, you can bring me back there. I'm making very big assumption about what you all know about freight or what you know about the research that happens in the US. With this, I'll get started with the topic as discussed multiple times in the introduction and before. My name is Sushant. I work with Texas A&M Transportation Institute, and the topic is freight technologies and strategies for a resilient future. Of course, the topic is very broad and deliberately kept like that so that we can cover different works we have been doing and also the research or new things that are upcoming in this area. I go through this. So my talk, the way I developed is I kept it divided into different buckets, I'll say. Something about planning for the future, what's going on in terms of freight. And now when I use the term freight, I'm very specific towards, if you have to think about it, the movement of goods on trucks. That's what the freight we'll be talking today. We'll not get into the rail part. Yes, there is a research being conducted. We do research in that part, but I stick to this one because majority of the freight that's carried in the US is on trucks. 80% of it is on trucks. And that becomes a bigger problem. Not that the rail is another different animal in its own sense. It requires a different types of research. So the first one I'm going to go through related to planning for future, what's coming, autonomous and electric trucks, truck only lane for those trucks. So does it make sense? Then we get into energy security, emissions and all. I'll talk about freight mobility and wind energy, which is a big topic here. Smart border crossings at commercial vehicles, for commercial vehicles. That's another one which we are working on. Freight resilience has become, and resilience by itself has become a big topic, and I think all of you will agree over the years, seen so much change in climate and weather, and in the infrastructure is still being pushed to its limit. So we haven't thought about resilience before. We were more into sustainable solutions, but now we're getting into resilience, boundary of resilience, where we're thinking about what will happen in the next 100 years. If the weather changes like this, and these is happening as we speak. So that's another topic I'll talk about under emergency freight movement. And in the end, I'll conclude with some of the new topics that are upcoming, are about to there were some good news in terms of logistics and freight. One thing is physical internet, another one is drone delivery and last mile solution. These are big problems. If you're in the world of freight, these are very, very big problems. And I'll go through that as well. So if we take a step back, and you may have heard autonomous vehicles, right? So it's a very big term. We are seeing those vehicles on the road. Electric vehicles, we were seeing those on the road as well, right? So both are happening more so in the world right now. And both these technologies are actually starting to overlap, where we are getting into the world of autonomous electric trucks. Autonomous trucks are running in Texas. They have been so many tests over the last 3-4 years that it's no more new news. You can hear about them, you can see them driving. Electric trucks is more of you see some on the roads. They're still in development phase, but we are reaching a phase where we're talking about autonomous electric trucks. And some of the infrastructure is in place. Some of the charging stations are there, but there are bigger questions that we are trying to address here. Electric trucks require an entirely different charging system than electric vehicles. Autonomous trucks require a different kind of infrastructure. And why it is getting more popular is because of one of the problems that we face in the US is driver shortage, truck driver shortage. It's because of multiple reasons. It's a hard job. It typically doesn't pay very well. Even if it does, it requires a lot of effort, and there are so many regulations that binds a typical driver, that there are not enough facilities, hours of service. They can't drive more than some X amount of hours. They have to take mandatory rest. They have to do things which are not in their control, like driving during congestion, and they have to make a delivery on time. So all that is happening. And one of the questions that came up was, how do we make these autonomous trucks that are being developed or other new emerging technologies more efficient while not creating a difference, while letting it coexist with the existing system? And one of the ideas was, what if we have truck-only lanes throughout the corridors? What if they drive on these lanes that are dedicated only for autonomous trucks or trucks? So we started studying this, I think a couple of years ago. And this is what you're seeing in front of you is a Dallas-Fort Worth metro region, and there's an Interstate 20 that goes across the country. And on this Interstate 20, there is a 32-mile corridor, which was selected based on congestion on the road, especially related to truck congestion and truck-related presence of trucks on this road. So what you're seeing is this 32-mile, which is like around 50 kilometers long corridor, which was picked. And all those dots show you different interchanges or intersections, bigger intersections or interchanges that are here. So we started to question, what if this whole corridor is truck-only lane, and they don't need to interact with cars? And that's a big problem, right? Interaction of trucks and cars becomes a safety and operational issue. So to study that, and the question was like, what if there is a truck only, and how much efficiency we can derive out of it at the network level and also at the corridor level, and is it even feasible? So to study that, we looked at something called multi-resolution modeling. It's been in there in a while. What it means is by multi-resolution is you zoom in and zoom out at the network level. So you zoom out and you can see what's happening at the whole transportation network level of the city. So you see right now you're seeing a network of Dallas-Fort Worth. And then when you zoom in, you get into the specifics of the micro simulation, or you may have heard the word traffic simulation. Then you look at the cars specifically driving on the street and all that. So we did this to understand what kind of efficiency can be achieved by turning a corridor into truck-only lanes. And there are some different bottlenecks throughout this corridor. For example, this image on the bottom left is showing where we have a very high gradient. Trucks have to climb, and because they have to climb this uphill, they slow down, and because of that, all the traffic behind them slows down. And truck, as you know, are heavy vehicles, so it takes a little bit more energy or acceleration for them to go higher up, and then it creates a congestion, and it's going to be a big challenge for eliminating that kind of issue. But this is what it is. It's the geography of the region. So the idea was, these are small different types of bottlenecks throughout this 33-mile corridor. What if we have truck only and we don't allow them to interact with cars and trucks? What will we see in terms of efficiency? Another screenshot of a simulation part, but not the complete dynamic traffic assignment and other, but only micro simulation. And what we saw there was, okay, we can do that. We can do this at the corridor level. It kind of makes sense, but when we looked at the network level, it wasn't making much difference. Of course, it was kind of expected, but the reason it wasn't making a difference, even with such a long truck-only lane, it wasn't the efficiency, but it was in terms of the cost of developing this infrastructure was higher than the benefits that were being derived. And the benefits were lower partly because so many interchange are there throughout this corridor that it's impossible for you to gain that efficiency that you would like in the system. So we could see, like 10% of truck traffic will switch to these truck-only lanes, but that's it. The rest will be going to different parts of the network in the city, and that will not allow that much of efficiency. We looked at the safety issues, how many crashes will be prevented by doing so. We looked at this problem from different angles, but overall the result was like, we were not there yet. We still have to plan these truck-only lanes as this entirely different system. It just goes across the whole corridor. It's kind of a bypass to the, for lack of a better word, and that is just for trucks. We can't just add one more lane and create a system there, which will turn out to be good for autonomous vehicles or electric vehicles or regular trucks. The second challenge which we face in the state of Texas is related to border crossings. And there's a city, and I'm showing you a border of US and Mexico. And there's a city named El Paso, and we have a very high emissions in this city. And a part of the reason is because these trucks are standing in the queue to cross the border, and they have to go through those safety checks, documentation, and all that. And the typical delay in this region is like 1 hour to 2 hours. So it's too high. And the problem we were trying to solve here was, what if these truckers and shippers have information ahead of time? How much is the delay at the border crossing? Will they be able to select time of the day they want to leave, and then reduce the congestion in some sense? So what we did was develop an AI or machine learning-based predictive wait time and crossing time system. And there are 2 types of lanes at the border crossing: fast lanes, which is like, you already have the information of these people who are driving the truck, what's in the truck and all that. And then non-fast lanes, like where, and they pay some fee for fast lanes. So it's kind of a paid toll. But the question was, how better can this be predicted in terms of, ahead of time, if you leave at this XR, let's say 6 a.m., how much delay you will face at the border crossing at this typical time. So what we did was developed this algorithms and different methods, try different methods to predict the future wait time and crossing time on these border crossings. And this turned out to be a very interesting project because we were able to predict with a reasonable accuracy using different methods. But the question was, how do you provide that information? So that system is still being commercialized, that how truckers can receive that information on their apps. And not only truckers, the shippers. So they decide when to send the shipment across the border from Mexico side. There was another challenge related to it. So this is El Paso City at the US-Mexico border. It's towards the US, El Paso, where we have different land uses. And the question was, a lot of these trucks which are crossing the border are also have to park and have to stay in different part of the network, transportation network in the city. And the question was, how many trucks are staying within the city for how long? And how do we calculate that based on the land use? Because some of the residents were complaining that these trucks are there parked for longer than what they're expecting. So what we did is we used the GPS data, the probe data that is very much available from different providers. And then we looked at their mean parking time, how much time these trucks are parking. So what you're seeing here is on the right side is that yellow bubble is showing how long the trucks were parked in this region or this location. So we were able to figure out, some of the residential area where there is a lot of parking happening, more than 12 hours, and there are other places where they're parking for some few hours. So we were able to figure out that, and then we were able to utilize that information, making sure that at least we know where the truck parking is not available or what other issues are there. There are different issues there, why they are parking in these locations. The third one, which I want to navigate into, and I mentioned this is related to energy security, right? So transportation of permitted wind energy loads. But before I get into this, if there is any question about the previous two works I described, I'll be happy to take it right now, or we can wait till the end, whichever way you want to address it.
Sir, can we continue with the presentation, or Shahim sir?
Yes, definitely. Continue with the presentation, and finally we will ask, sir.
Okay, sure.
Thank you.
So now with the wind energy loads, and when I say wind energy, we're talking about wind turbines or windmill blades, and anything related to wind energy that is being installed. So in the US, wind turbine installation, if you look at the wind turbine installation density, that's you can see this map on the left side where we have provided the density of wind which are being installed. It's easy to see that some of the region in Texas has lots of wind turbines, partly because of geography as well as the need of the state. So in that sense, Texas in the US is a leader in terms of wind energy. Like a quarter of or 1/3 of the wind energy capacity is there, and wind energy is being installed and used. So wind energy makes up to 25% of the generating capacity and 24% of energy used in 2023. So it's a big thing. The thing about wind turbines is it has different parts, and some components are, naturally don't come into transportation because they are either built in the location, the field where they're going to install. But then there are bigger components like towers, right? So I'm showing this is tower. This is a very big component. Machine head or nacelle, we call it this one, and the blades, the windmill blades, they are very long. They're big. So transporting them is by itself a big issue. And what we're trying to do is try to understand where these loads are coming from, where are they going, what are the challenges they face while transporting, and also what are the trends over the years, what's going on there. So in the US, there's a term oversize and overweight, which is used, which means there anything beyond the legal limit, which the legal limit here in pounds is 80,000 pounds. And that if that exceeds, then you go under overweight categories. And there is also dimensions of loads, and if those exceed, you're like oversized. And most of the loads are related to windmill blades and wind turbines, all that come under oversized, overweight. And that data is available. Partly it's a safety issue, right? So you're carrying such a big load, which is beyond legal size and weight. It may cause safety issues. It may cause payment infrastructure issues and all that. But it's also necessary evil because it provides economic benefits. Regulate, there are other benefits to it. It helps industry, energy security, and all that. So you wanted to make sure that these loads are able to transport, but then you want to permit those, and each of those loads that are moved across the state have a permit associated with that. So what I'm showing here is the wind energy related oversized overweight permits over the years, right? So from 2018 to 2023, we have seen an increase. During just pre-COVID, we saw an increase in number of wind energy related oversized overweight permits. And what it meant to the state is what I'm trying to address by mapping this. So Texas is like, it's equal. I try to make it equivalent to what all states combined will make Texas. So if I do that, we have an area of 695,000 square kilometers, which is Karnataka, Tamil Nadu, Andhra Pradesh, Telangana, Kerala together. That's how big the state is. And what happens here is there are different districts in the state, and then there are counties. So there are 25 districts into the 4 counties. And what I'm trying to show here is the number of wind turbines installed in different counties. So the name of the counties where more wind turbines are, we're showing it here. What is interesting is this: you will assume that the counties where wind turbines are installed, they remain constant, but that's not the case. Every year, the wind turbines are being installed all around the state where geographic permits, and there's a the wind is there for it to really produce something. So the trend showed us that one, the wind turbines are in particular region. We can see the number of wind turbines that are being installed every year does not stay constant. As the county gets saturated with number of wind turbines, it keeps on moving, and it's not like just next county and all that. It's kind of moving around. That means all these loads related to wind energy, all the components that are being transported are also being transported to different places. So either their origin or destination is over there. And then when I talked about the blade vehicles, so this is on the right side, you can see this is a windmill blade. It's way longer than what you see on the roads typically. So what we did is, well, we tried to map that data in a sense, like what is the weight of the typical median weight, median length, and median gross vehicle weight. GVW is gross vehicle weight of those loads. And what are the longest blades which are out there, and what is the median length of those blades, and what are the heaviest gross vehicle weight? So try to convert that into SI or metric units. So what we see in 2021, we had blades which are like 100 meters long, which are being transported, and the weight were around 113 tons. So it was very heavy compared to a typical load seen on the road. And then same in terms of median gross vehicle weight, this was there. The trend has been almost similar. It's not changed much, but we see these bigger loads that are being moved, and infrastructure is not built specifically for these loads. They are made for typical loads we see on the road. Same goes for towers, where we see towers which have a very high weight. 172 tons was the highest that was seen. So towers are not very big, but they're long, like the windmill blades, but they are heavy. And then we can see that they are very heavy towers which are which can be seen on the roads. And then there are like machine heads, which can be more heavier than the towers and the windmill blades, going up to 230 tons. And all this load is being, like this is just an example of one load here, but these numbers are very high every year. They're in thousands that are moving and are being transported every month, and then eventually multiple thousands in the year. So what we do is we try to understand that, okay, where are these loads are coming from? Are they coming from out of state? They are internationally being shipped. How do they enter the state of Texas? So what we have is a map of different roadway networks. This is just in Rayliat, where they are also transported using trains. but not many of the milk bales are transported using trains because it's still economical to transport using these oversized overweight trucks, the specialized trucks that carry these. So we map that based on the blood some sample, and also map different interstates that pass through state of Texas. So we're looking at these all networks and permit route segments, and wherever these this blue is showing where more load is moving in terms of wind energy related loads. And these are the interstates. These blue are in different interstates that pass in the state of Texas. So in a nutshell, there's a lot of wind energy related movement happening in Texas. We are trying to understand the infrastructure related issues, how the existing transportation infrastructure is ready, because these loads require a clearance height for between bridges. They require those bridges to carry that much weight. They should not damage the bridge and pavements too much. So those are the infrastructure issues, transportation issues that we try to address or understand using this information that comes from the data. And then we provide that information to, in the US, it's state DOTs, equivalent to PWD, I'll say, where we try to work with them to understand the infrastructure needs and what needs to be built. I'm going to switch a gear here into freight resiliency, but at the same time looking at the perspective of COVID and emergencies. And this was more of a policy research. What happened during COVID was there was a need for emergency supplies. And emergency supplies, if you're trying to during COVID, if you're trying to get those emergency or medical supplies within the legal limit, it was a little bit inefficient because you can only carry some weight. And what a lot of states and the country realized was that we need to move these loads quickly. So there was emergency permits that were issued for heavier loads, which I call oversized overweight, which are beyond legal limit. When these loads were moving from one state to other, what was found is every state has their own regulations related to what weight can be carried, because there are a lot of infrastructure in the state that cannot sustain one kind of a weight. For example, a bridge in state A can carry, let's say, some X amount of tons only. It's built for that, and then another state it's Y amount of tons. Then you have different geographies, right? So they have to navigate those clearances, different type of geographies, and all that. So there's no harmonization in terms of what is permitted in different states. So a national study that came up and that was related to regulatory relief of commercial vehicle weight requirements for emergency transportation of critical commodities. And emergencies are increasing, like every time we see these bigger hurricanes. Pandemic was one example, but there are other that are happening every day. So those emergencies are blizzards, snow blizzards, and all that happen very often. So we wanted to make sure that we understand what the issues are and what needs to be addressed. So this research was mostly about understanding what is the definition of emergency, because there is not one. How do different states define emergencies? Can we come up with subset of emergency commodities? Like, these are always needed. Identify successful practices and procedures during emergency, what worked during previous emergencies, and how we are able to harmonize and coordinate between different agencies and get these loads from where they are to where they are needed. Otherwise, they'll be stuck from one state to other. They will not be able to traverse from A to B locations, and most of them are going many hundred miles or kilometers, typically sometimes 800 kilometers. So that covers different states. Then we developed a decision framework on considering it and highlighted some successful communication practices. This was more of a policy study than an analytical study. So what we found was like there's there was a misunderstanding about what special permits are and what waivers are. So we tried to address that in the study, that a lot of truckers or a lot of carriers or a lot of even decision makers have a confusion about what special permits are and what waivers are, and we try to address that in terms of who provides waivers in terms of agencies, and then who provides special permits. Then as part of the study, we also looked at different definitions of emergency, what exactly emergency means, where does that word come from, how different states can redefine or at least try to define. And we were able to find that, it's kind of given, the definition of emergency is given in the executive orders that different state leaders like governors and presidents declare. So the question was, how do we tailor it to the kind of commodities that are needed? Is there like a generic list that can be included into these emergency lists? So we developed some steps how to develop that emergency commodity list, which kind of is based on all the emergencies that have been seen in the past. And based on that, we tried to guide different states how to develop that. Then getting into like why there's a variation in this special permits. There's a variation because different states, and you don't need to read everything here, but what I'm saying is different states have different resources and staff available, and based on that, or maybe sometimes they have different third-party vendors that provide information on their website, and that there was no harmonization in that sense. So different states approach it differently, and what are the solutions there? We talked about that. We talked about how different loads, there are two types of load, divisible and non-divisible. Non-divisible, if you think of it, is a big load like a crane, which is on behind a truck. You can't divide it. And then divisible loads are like, you can divide it into smaller chunks, and then you can put it in different trucks, even if like, you can go above a particular threshold of gross vehicle weights and limits that are there, but you can divide that. So we talked about those. There's confusion about what can be considered divisible and what can't be, and develop this roadmap for success. Like, how do we go about it? So how do we develop consistent framework? What are the promising practices? What are successful ways that have been tested in the past? And then we got into emergency management cycle, like this, how this should be addressed whenever there's emergency, how these loads, critical loads, need to be moved during emergencies. Some kind of a pre-disaster plans, like what we should do before disaster, and then post-disaster plans, what should we do after disaster. So these were provided as a part of a guidebook that was developed, and also a final report that came out of this study. So overall, what we tried to do here was understand what are the policy level and regulation level issues. There were some data, but not enough to do anything related to data analytics and all. So we provided some input there. Now, the question related to freight mobility is, what is the future of freight mobility? What's going on right now in terms of freight? And one thing we have been able to see over the years is a need for a sustainable freight, right? So something that can be carried across. And the term that has come across is you want to, it's kind of hard to digest the term physical internet, but you have to think about it in terms of logistics, in terms of the containers you may have seen on trucks, or those containers that you might have seen on the shipping yards and all. And the idea is very similar to that. Like, many years ago, when the containers TEU, we call it 20-foot equivalent, came up, it appeared, they kind of solved that problem of moving the things around. We kind of standardized it. But what happens is, that's the biggest container. We haven't boiled it down to smaller packet sizes. And smaller packet sizes is like, smaller containers, which are like standardized. So the idea here behind physical internet is like the way internet works, there are like smaller packets that travel. The same thing is, what about we standardize the containers at the smaller level? And that's what the whole idea was. Because one of the biggest issues we face while transporting freight is there are some inefficiencies. The infrastructure is not being utilized because they're empty trucks, because they don't have enough space, and they don't have any load that fits in those containers. And there's a lot of wasted space in containers. There are empty trucks and all that is going on while we are working on these new technologies which are coming up, blockchain, AI, and all that. We feel these containers are like at a smaller level, smaller standardized containers, then you will be able to track them efficiently, and you'll know what's going where and all that. So that is the idea behind physical internet. And it's been championed in the last 10 or 15 years. It's still like in early stages of implementation, but it has a big potential in terms of changing the logistics and transportation industry, because this will definitely reduce a good amount of carbon emission. It's just that for standardizing at that level, you need different countries to work together and come up with some similar standards, and then it does not stop at the level of container. You need technology that supports it, some kind of technology that tells us where this is going and all that standardization of stuff. So that's a big idea in terms of mobility of freight. The other one, which is another bigger issue in terms of if you talk about only freight industry, is last mile delivery. Last mile delivery is the biggest inefficient thing that happens with movement of freight. Think about your Amazon or other goods that you order online. It's easy to get them near you, but it's very hard to get to the house of a person, because depending on where you live and all that, and that is a very big issue in terms of movement of freight, because it requires a lot of energy and creates more emissions. 20% of the emissions are created by that. The solutions that are being tested right now are outcome of what we saw during COVID. We saw drones can deliver healthcare needs. We saw that drones are good as long as they are away from the risky airspace. They're able to efficiently deliver some of the things. Then we have these new vehicles that are actually delivering kind of groceries and all those needs to consumers. They're called autonomous vehicle delivery. So those are some very interesting ideas that are being worked on, and some of them are being implemented. So I still see that there are like some solutions related to drone delivery, which I personally witnessed in my neighborhood, are being utilized. Although I'm not a big fan of it, because you see your drone comes in your backyard and delivers something. What are the chances that it will stay? First of all, the delivery will be perfect, depending on how fragile the things are, and second, is it safe enough if it's in your front yard? That's another problem. And there are other things, but these are solutions that are being tested in terms of last mile delivery. And I think that's it. That's the end of my presentation. Thank you for listening in, and I'll be happy to take on the questions now.
That was an enlightening talk, sir. Thank you. The forum is open for discussion. Any questions or queries?
Sir, we have a few questions in the chat box. Let me read it for you, sir.
Yeah, go ahead.
The first question is by from NATPAC. The question is, how effectively does the human driver vehicles and AV coexist in Texas? Or is it that AV trucks fly only on dedicated corridors? How could the transition from HDV to AV can happen in a developing country like India? That's a question, sir. There is
Okay.
one more question. I think we can take this question first and then move forward.
Yeah, I think the most important aspect of AV is lane-based driving, and even in the US, you don't have these autonomous trucks are not driving on specialized corridor or corridors made for them. They are driving along with human drivers. So the testing that is happening right now over the last 4 years is there's always someone sitting behind the wheel, and the truck is driving autonomously, and all that has tried to the good extent, because on the interstate for longer haul or longer run, they are working out fine. And in the in the US, it's mostly lane-based driving, so it's working out fine. The question, if you ask me how this can be successful or how this can be implemented in terms of developing countries where the lane-based roads are not there, I think the tests are being autonomous vehicles in India. I feel like if they are successful, something on the same lines, but with dedicated freight corridors, dedicated freight lanes, that will work out better than trying to introduce this to a regular roadway network. And that's kind of obvious answer, like whoever has asked questions, this might be very obvious that, okay, for these to work out good in countries where there's no lane-based driving, it has to have a dedicated corridor. So that's the answer.
Thank you, sir. There is one more question. How can freight transport be effectively planned in emergency times of disasters like landslides and floods?
Can you repeat that question?
Yeah, sure. How can freight transport be effectively planned in emergency times of disasters like landslides and floods?
Yeah, for that you need that's what we talked about. You have to have a pre-disaster planning. You can't just assume, and post-disaster as well. What the lessons we learned during COVID and even during other emergencies is like, you have to have an emergency management plan. If there are landslides, you have to have some kind of a alternative route planned out. Because what happens is with all these emergencies, which we have seen is like, it's increasing in terms of frequency. If we don't plan right now, at some point we are bargaining with the economy as well, because freight kind of moves the economy. We know that. So if anything like that is as a possibility, I feel like we as a state agencies, we need to look at that and look at the resiliency of the system in that sense. Like, what are the alternate routes if this happens? I know Kerala has recently seen some landslides and a lot of flooding recently. So I think that those things have to be thought about a little hard. And I think the recommendation should be on line of, you should have redundancy built into the system. You can't have just one bridge that goes from A to B. You have to have like multiple systems like that. And that's how the resiliency planning will work for the future. For freight, it's more important. I think for even freight is more important because that's where you're taking those critical commodities which are required. Emergency supplies are gonna be part of freight that are being delivered, and that's what we want to get to across the populations. So at the very basic level, that planning should incorporate these things. And there should be a plan for pre-disaster and post-disaster. If you don't have any, there should be some other ways of delivering those medicines, like drone delivery or emergency supplies by air and all that. But there has to be those plans.
Thank you, sir. A few more questions from Mr. Anish. So the first question is, are there any travel restrictions to the truck movement like in India? So that's the first question. I'll take up the second question on, while transporting such heavy equipments, how is the damage to the pavement taken care of? In India, there is a lot of overloading movements happening, so concessionaires want them penalized. So how is this issue handled there? So these two are the questions.
Yeah, so the first one was related to, I think the first one was related to the regulations.
It is related.
So
yes, sir. The restrictions to the truck movement.
Yeah, and there are tons of regulations. There are tons of regulations which trucks can come, like, what time of the day they can drive through the cities and all that. Have agencies, as I said, there are special permits and waivers, like how much they can drive, which cities they can go. So there are like some overriding, but they are based on, and I'm talking in context of emergency. They are overwritten only during emergencies by the emergency declarations, because right now the need of getting those things across is more important than the noise they create or the pollution they create. So that is a different problem here. So in terms of emergency, yes, they have to navigate the regulation, but there are some waivers that are provided for some of the things, some very commonsensical regulations. But yeah, often the truck drivers who carry this for the front end during this are not aware of these regulations sometimes. So they have to know what's there and what's not there, and what waivers and special permits they're carrying. So there is a little bit of education component involved in this. There are a lot of regulations. The follow-up question related to damage to the payments by these loads. Yes, there is damage, but that's why the permitting system is there. So when they are given permits, they're given based on some kind of understanding. Okay, these loads. First of all, they have to pay for that, right? So permits require some fee, and that fee is calculated based on what damage they can do to the payments. Now that damage, the way it's calculated, there are a lot of studies that we are doing where, like the way we are asking for permit fee, is it the right function of the weight, or is there other factors that needs to be involved, like payment type and all that? Those are being studied in parallel, but there is a fee that is used for repairing the payments. But also there is the permit itself tries to address part of the problem of realizing that they only drive on those payments where they will not create a bigger damage, that is concrete roads. And they also go across those bridges where they will not create bigger issues. But very often we see that sometimes the bridge clearance is like, let's say in the US, we talk in terms of feet. So the bridge clearance is like 16 feet and the load is 17 feet and they get stuck under the bridge. So in that case, there are other penalization methods that might be used. But right now, the permitting system itself takes care of most of the problem, not all.
Okay, sir. One more question, sir. With the increase in online shopping and home delivery, it is understood that the waste is increasing at the household level. Has this aspect been studied?
Yes, and it's being studied at all levels. Even the companies that ship, like for example, Amazon, everything they are shipping, that goes under. They try to study that as well. So most of the packages that are arriving are in recyclable packages. They have a footprint, like still there's like some enough, you see these packages, like you just order a small thing and you have tons of big stuff, that plastic that comes with it. That has been addressed from different levels. What they are trying to do is, at the industry level, what they try to do is they give consumer an option to consolidate the deliveries, one. Second, they are also giving the option to consumers to go and pick them up from locations where there will be like the package will not be in a box, but they are as it is, as in the packing they come. So they are in their original packing. And then there are other various studies that have been conducted related to, like, how bad the situation with e-commerce is compared to before it. So I think the answer to that question is this is not going away, right? So everybody wants convenience. It's just that industry is trying to work on their solutions. Public sector has to work on their solutions. And as a consumer, we are looking for our own solutions, like which we may have to develop, either be very mindful about when we order, in terms of how many packages we order, how we group together the orders, or how do we dispose of this recyclable material. If there is no recyclable material, we have to think about how we dispose of or use the plastic which comes with it. So the studies are there. Like the answer to this, a short answer to this question is there are multiple studies that have been conducted by industry and by academia. Industry had tried to improve on that. Academia is just pointing out, like, okay, what else is needed. But I think overall, consumer awareness is also required along with that.
Samson sir, Dr. Samson sir, our director is also present in the meeting. So sir, any questions, sir?
Sushant, thank you for a wonderful like a presentation. Of course, this like a goods movement is one of the important topic. Probably we have been discussing that one for so many years, but and the dynamics of the movement is also changing. I'm very happy that listener you have given a wonderful presentation, and our people also they could interact with you. Definitely, this is a very important topic, and especially when the vehicle technology, automobile technology, when it is changing, and the type of the movement which the delivery which we are expecting from the consumer to the, or from the supplier to the consumer. It is a big the question to be answered, and it is very dynamic and it is changing from time to time. Thank you so much for the presentation, good presentation. Probably others also can interact. Thank you, Shahim.
Oh, sir.
Thank
Sir
you.
Sushant, sir, I have some one or two questions, sir.
Yeah, go ahead.
We have preparing some city plans and all. So how to integrate this urban freight transport in city planning? Because we are neglecting this freight policy and transport in the city planning.
Yeah, I think I've seen that very closely. What happens is a lot of city planners are they take sides in terms of like what's important and what's not important. What happens is like they understand pedestrian and bike is important. We need those for users, but we also need something for these goods that are moving across. These are necessary. And when we plan around this, let's say there is a big warehouse being constructed, you have to think about where those trucks are going to park. You have to think about in a case of city, what kind of calamity can come and what kind of disaster may happen and how we are going to address it and what will be those routes that needs to be incorporated into that. So city planning has to be a little bit more the city planners have to be a little bit more cognizant in terms of they need to be educated about what's needed for freight mobility and why it is important. Why freight is important. You can't just say that the residents are saying that these trucks are making noise and we don't want these trucks. Well, the same residents are asking for those deliveries, same day deliveries, or for the same Amazon goods. So a city planner has to be careful about what they wish for, and also understand that it's not completely part of the problem. It's a part of the problem that they are trying to address. So you can't just ban the movement of trucks. You may have to find a solution for those trucks before you go into these specific regulations. I think that more and more there's the e-commerce has created this new problem that wasn't there before, but it has to be addressed by keeping in mind that it's being driven by consumers, which is like whom city is serving as well. So we are trying to look at different solutions, curbside delivery, other kind of deliveries which can happen, maybe smaller electrical vehicles that need to go for the last mile. All that has to happen. And when you're planning a city, you can plan warehouses around, not in the neighborhood, but maybe around the city periphery, and the last mile is being done using these electric vehicles or autonomous vehicles or whichever is a workable solution that go into into the city.
Sir, whether this freight movement is affected by land use planning and zoning and other developments?
Can you repeat which movement?
Whether this freight movement is affected by land use planning, zoning, and when you are doing this thing, this planning sort of things, we have to consider the freight movement also.
Yes, you have to. That has to happen. And that's the outcome of whole e-commerce movement in the last 10 years. land use is the biggest component related to it, and you have to think about it a little bit more. The traditional way of thinking about land use has to be changed to accommodate all this the movement of freight that's happening in terms of the goods that are being delivered to the house of the consumer. So that has shifted a lot in the last 10 years.
So then one more question, sir. How freight transport can work with other modes to reduce the emissions and achieve low emission and mobility, sir?
Yeah, so one of the solutions that is being tested around the world is related to using public transit for moving goods. So that's a very interesting solution. You're using public transit for moving the goods that need to go to the consumer's house. This is where the public transit and freight overlap each other and produce a very interesting solution. If you have a very good public transit, then I think utilize it for last mile delivery as well.
Okay, sir. Thanks for your nice presentation, sir. You have actually done a very good presentation. We have got many ideas and many interesting things in the freight transport that we are neglecting so many years, sir.
Well, thank you, everyone who showed up this late. And again, I know this is a Friday evening for everyone, so thanks for all your interest and participation. And thank you, Dr. Matthew, for inviting me, and thank you, NATPAC and Anish and everyone. Have a good weekend.
Sir, we will have a formal vote of thanks, sir, also. Yeah, Anila.
Dear one and all, on behalf of NATPAC, I would like to extend my heartfelt gratitude to each one of you for joining us today for the TransTech talk on the topic Freight Technologies and Strategies for Resilient Future. Our sincere gratitude goes to Dr. Sushant Sharma for his interesting session on the approaches for shaping the future of freight transportation. Dr. Sharma, your discussion on the physical internet and smart logistics has shed light on the transformative potential of optimizing freight movement and how it can be used to enhance efficiency. The discussions on drone delivery, last mile solutions, autonomous trucks, and smart border crossing were thought-provoking. We are grateful for the knowledge you have shared us with today. I would also like to express my gratitude to all the attendees for your presence and active involvement. I would like to thank our director, division heads, and the organizing team for their support that made the smooth execution of this program. I believe we have all gained valuable insight from today's technical talk, deepening our understanding of freight technologies, which will undoubtedly guide us towards planning a sustainable and resilient freight transportation system. Once again, thank you, Dr. Sushant Sharma, for your exceptional contribution. We look forward to many more such enlightening sessions in the future. Thank you all.
Thank you, Sushant, sir. We will be in touch with you, sir. Thanks.
Thank you.
Thank you, Sushant. Thank you.
Thank you so much.